Hi, everybody, and welcome to tonight's edition of Tech Savvy. Today, we're talking about Cloud9 or Cloud9, featuring Moni Petkov. I just couldn't do
I
the
noticed,
accent. Yeah. Today, we are joined by the Chief Architect of Scale Focus, Simeon Petkov, and we'll be discussing the finer things of cloud and the different aspects of the world that cloud created for us, the interesting insights and developments of cloud technologies over the past few years, and generally have a discussion about where cloud is going and how we came to the cloud we have today. So, Moni, can you introduce yourself maybe briefly, and we'll start with the topics.
Yeah, sure. So the pun in the beginning stems from, since I'm supposed to give a short CV or something like this, because I grew up in a German-speaking country, and Krasi doesn't miss an opportunity to make some German puns whenever I'm around. So that's the small thing behind the title of today's session. As Krasi said, currently I'm the Chief Architect at Scale Focus. I've been a software engineer for a very long time. I started programming when I was about 11, I think, on Turbo Pascal, which is a very long time ago. I studied computer science, and I've gone through a pretty much what you would call straightforward career. Developer, integration consultant, team lead. I've been CTO of a very small company for a while. And in Scale Focus, I also transitioned to quite a few different positions. Again, integration consultant. I led a unit for a short while. And currently, we are working strongly on architecture, which today is kind of inseparable from the cloud. The cloud had a lot of effects on software architecture by itself. Even so much that it kind of affected the way that we design on-prem systems. Just due to the experiences and the things that we learned on the cloud, we even changed this approach, so to say. And at the moment, I'm also involved very much with new clients, with pioneer developers, wherever things get a little bit more tricky, whenever we can't find anyone in the company who has done anything. Quite often, I'm the one to experiment a little bit. And there's also the reason, I'm guessing, that I'm here, that this also accumulated a little bit of experience with some interesting approaches that we had. And yeah, that's pretty much it.
Okay. So the obvious question is how we started with cloud, where are its origins, how we came to the cloud we enjoy today or not so much enjoy, and maybe a brief introduction of how we came here and also the state of cloud in 2024, since a lot has changed in the past 5-10 years with cloud.
Well, definitely. I really don't feel that I have enough expertise to say on a general level what the state of cloud is currently. But from my personal experience and also from what I see happening around is that there are some interesting things happening. You could say that like the big hype might be over, so to say, in the general public. If you think maybe, I don't know how many years it is, 3, 4, 5 years back, there was this point in time which happens with every hype curve, just the way that you currently have it in AI. If you don't have AI on your company, on your product or whatever, there is no funding for you, nobody pays attention for you, you're boring, you're old school and so forth. 5, 6, whatever the number is, years back, if you didn't have clouds on top of your product company or whatever it is, no one paid attention to you. You should have a branding which goes in direction as a service, cloud native, and so forth. As with all hypes back then and now, some of them were really cloud services, others simply had it on their name. The current state, I would say, is that it's still developing, maybe not so visibly as it was before, but it's that there is a definite upward trend. There are new things which are interesting. Actually, not new, but they are becoming relevant for a much broader and broader audience. Like, for example, multi-cloud setups, that people actually become conscious of the idea that they don't have to stick with only one. Edge computing is becoming more and more relevant any day, and growing. And also, to make the circle back to the current hype curve that we're currently in, which is AI, there is a brutal synergy between AI and clouds, because simply the requirements that you get from the current AI platforms, especially the now extremely popular LLM platforms, they have very, very specific and quite heavy requirements on the infrastructure that you run them on. And many of the participants, it's not really a matter of choice for them. They don't have another option than to simply use them on the cloud. So there are many things happening. I think it's more relevant than ever and still kicking.
Yeah. I would like to add, by the way, as a rule of thumb, I use the registration of top-level domains. So back in the day, everyone used to register .cloud, and now everyone registers .ai. That means basically you're at the top of the hype curve. The hype curve when that happens.
I never thought about this, to really check the number of registered domains.
And many companies even register their used to register back then their company name,
the original
cloud,
one with,
and now they register whatever .ai. So that means that cloud definitely had its hype days, and then it went back a bit, and now it's in the plateau of productivity, or whatever it was called in the Gartner hype cycle.
Hype is definitely down, yeah.
And to me, cloud is an obvious development, since a lot of things that needed to exist in order for cloud to be. Like in the 90s, we had virtualization. In the early noughties, we received more stable infrastructure for connectivity between countries, and so on and so forth. Fiber optic highways started to appear, especially in the European countries, and also in the US and so on. And that made basically centralization of storage and true virtualization and compute possible, because you have all the infrastructure necessary, and cloud was a
natural,
it's a natural offshoot of having the prerequisites. And today, I believe cloud, it grew, and we'll discuss a lot of the things that it impacted today. You mentioned some of them, like architecture, how we architect things. But cloud became something personal. It's the penetration is so deep now that most of our personal stuff, like pictures, like family videos, whatever, everything is on the cloud. It used to be this thing that corporations used to use for their data, and now everyone is using for their personal data. So in terms of penetration of the market is fully saturated with cloud. We used it for whatever we can. We'll talk at the end about the future perspectives of cloud, but definitely it's one of the hypes that stayed with us in the long run and really made an impact. And
it's funny that you say that for the penetration. I can remember in the very beginning when people were kind of pointing forward and saying, oh yeah, at some point your fridge is going to be connected and it's going to send you messages that something missing. I openly say that in the beginning I was like, nah, that's not going to happen. Like for some appliances maybe. When I look at my flat today, almost not the fridge, but pretty much everything else is connected, which is in there, and everything is controlled by cloud services.
Unfortunately, most of those cloud services are in China. But by the way, we, us too, we are not the best examples because probably our homes are more automated and digitalized than most. But definitely the same holds true for me as well. Everything that I could make intelligent or intelligent, I already did.
You have to play. Did you have this as a child? I had it. My parents were always mad at me when they brought me a toy. The first thing that I did was break it and see how it works.
Yeah.
Same thing.
Yeah. And there are interesting developments out of that. Currently, the current state of clouds is things like quantum computing, things like edge computing are more and more a thing. And it's, again, natural because we have more efficient processing with ARM processors and so on. They're ever cheaper. And of course, we can distribute them and they can run locally, crunch data, send it processed to the cloud. So it's a natural progression of things. On the other hand, we have interesting security developments because those IoT devices are not top-notch and the protocols they're using and so on. So it's an interesting thing happening today. I would like to change the topic somewhat and talk about an interesting impact that cloud has had that sometimes is kind of goes below the radar, meaning that cloud technologies started and actually developed quite a lot based on open source software. And while that was happening, cloud changed the open source it used. It started using it in ways that the open source movement does not like, frankly. In other aspects,
I see where
cloud
you're going.
has, in some cases, it's basically license wars. So you develop as a company, or the most notable examples that I know are MongoDB, for example, and Amazon and AWS relationship. Elasticsearch and AWS again, and different. So it's definitely impacted the open source movement more than anything else, because cloud, for the most part, when you say storage, when you say compute, when you say whatever, orchestration, CI/CD, most of the technology that is used on the cloud, even things like Kubernetes and Docker and so on, they're heavily used on the cloud, but they started off as open source technologies. Kubernetes, somewhat because it was developed by Google for their cloud needs, but they open sourced it. So it didn't start purely open source and then it went to the cloud.
It's different there.
But there is this dynamic that cloud influences open source and vice versa. So what's your take on that?
I think it's a complicated relationship, exactly as you said it, because from one hand, again, how do I put it? The resistance to use especially more complex open source tools, given the cloud, drops even more. Like when you have the whatever it is, a search engine, a database, whatever, when you get hit by it and need to operate it on your own, there is some resistance. There is like a wall that you need to break. You need to invest in operations and infrastructure and so forth. Cloud removes this completely. You have your open source tool and it's runnable on the cloud. So this is a good symbiosis where like an open source tool, which is like in the essence of it is being easily accessible, apart from being free, which actually doesn't have anything to do with the open source tech by itself, but most people kind of in their heads, free open source and open source is pretty much the same thing. This one brings the resistance even further down, so it becomes even easier to use. The other point, which is not so often being talked about, is exactly this. I also call it maybe cloud provider domination, which at some point appears when you, as a gigantic operator, take an open source tool, start operating and offering it, and not for free, but now you're starting to charge for this one. When you think back, open source companies are usually, or used to be, set up in a way where you have the free model where anyone can download your code and do whatever they want with it, especially use it. And they had an enterprise model where you can subscribe for, be it support or operational assistance and so forth. This is now becoming less and less attractive for companies, since they don't need you anymore as a provider. They have this gigantic company who stands there with their name and saying, we are going to operate this for you, and you won't even need support because we are giving you this as a SaaS with an SLA and with everything. And this actually cuts off quite of the feedback loop that the open source community had. So basically one very significant stream of income that they had went away. And this sometimes cloud providers are being criticized for this, that they're not putting anything back into the community, although they are benefiting from it. And I agree that this is a valid point which leads to some conflicts, and is currently a point which is just out there. You mentioned a few examples. I actually remember the Elastic one because I've had clients being confused because they thought they were using Elasticsearch on AWS, but they were using not really the one that they thought that they were using, but it was based on Elasticsearch, but a clone made by AWS carrying the name. I think there was even a copyright infringement case going on at the same time. So it had gotten that complicated. And obviously a company who originated the product wasn't happy about it. So it's an interesting development, kind of a love-hate relationship, I would say, so to say. It definitely acts as an accelerator, but it also brings in some problems.
Yeah, my concern with that particularly is as we go along, most companies, if you and Redis is another notable example. They had quite extensive battles, legal battles with AWS. Most open source would start usually with Apache 2.0 license or MIT, which are the more liberal licenses, and then evolve into something else whenever the cloud providers, the so-called hyperscalers, the biggest cloud providers, once they adopt it as a service, they change their license. And the problem with that is they change the license to enable them to receive royalties and so on for the massive usage of their product in the cloud. The problem is some of those licenses that they end up with hamper the usage on-prem or for small companies and so on of those same products. So open source used to be the obvious choice when you created the startup and wanted technology that works and is stable and so on. And now that's not exactly the case, because you need to delve deeper into those licenses. There are many, and they're being created all the time.
Licensing lately has become a nightmare. I don't know how you feel about it, but whenever we need to calculate pricing for customers for tools that were really easy, like you had like a table with a few columns a few years back, now it's impossible to predict it. Like you have to calculate how much your core will be exploited over what kind of periods, what IO, you have to know your IO stats for the storage, for basically numbers that no one can calculate or foresee for the future. And based on this, you get an offer for something that you're not even sure that you want to buy. So these are things that are definitely connected with the topics that we just covered. And I agree that they definitely don't make things easier or better. It's just like something like a side effect of these things.
Well, the obvious reason for that, and I agree with you totally. It's pricing is and it's based on abstract unit, like data processing unit or whatever. It's not like hey, you have 2 cores, you pay for 2 cores. No, there is always an abstraction that you pay over.
Exactly.
And that abstraction, you have no control over its generation, because it's quite hard based on the queries you run, or how you use your storage, or how you use your compute. Of course, you can give hints, you can configure some parts, but at the end of the day, the cloud provider is the one that decides how the technology works underneath the hood, and that ends up generating those abstraction units that you need to pay.
Exactly.
So
it probably makes sense for them, but as soon as you hit a client who has never used it and has no way of kind of predicting them, that's when it becomes problematic.
Yeah, absolutely. And we'll talk about the future of cloud and its impact later, but definitely the way pricing has been created in the cloud in the later years is definitely impacted. Another thing, and we'll talk more about that later in today's session, but the pricing models of clouds changed a number of ways throughout the years. So initially they were just storage and compute for most clouds, and it was pretty easy to say, hey, I have that much data, I do those computations, that's gonna cost roughly whatever. And eventually it starts being ever more complex, and part of the issue is all cloud providers nowadays have huge fees if you want to do egress of data, not so much ingress when you put data in, but when you want to put data out. And that is an issue for some business models. If you want to create a platform on the cloud that relies on huge amount of data being taken out of the cloud, at some point it becomes prohibitively expensive to run on cloud. But the cloud provider cannot do anything about it, because they have this pricing policy to protect them from you taking your data with you and going somewhere else. And that again is an issue once you, and of course if you're a small startup, you might not even think of those charges and so on, because the data is minuscule, whatever. And
that's funny with the startups, obviously, that the thinking goes, and that's exactly the way that you could even say that big cloud providers bait them a little bit. Your thinking goes, if I have that much data, I've already made it, I don't care how much it costs them. That means that I've done it. You have a whole set of different problems when you're starting a company. You have a little bit of experience with this, and that's definitely kind of especially egress, which I don't know, it's very professional to say it, but I think it's a very ugly practice. Basically, to try to bind someone to your platform by simply shutting the door, saying to get out, it costs money. And basically, they're, let's say, not so reputable establishments that that operate in that way. But the mere fact that big players like the large cloud providers need to resort to such matters means something. So basically, you don't have a product which is that obvious and such a commodity that you can't live without it, and that it also means that there is enough competition. So you might use a very similar service but for someone else, because one aspect of it is better somewhere else, which is actually, I think, a good pointer for competition and for the fact that there are alternatives, because otherwise you wouldn't have an egress fee. No one would use it.
Obviously they feel some competition, there is a rationale behind implementing such fees.
It's just what I like. It's like the most primitive way to try to keep someone, but anyway, maybe just a personal opinion.
And since we touched on the topic of how data providers try to keep you in their ecosystem, and when you by the way, a small digression on my part, but when we say cloud providers, we tend to take them as this homogeneous blob, but actually some cloud providers like AWS, they're providing certain services, but they're more of a pure cloud service provider, while as, for example, Azure, the second biggest player, they try to play as an ecosystem because they have their own programming languages, they have their own office suite, everything is integrated beautifully. You can easily integrate all the parts of their technology with their cloud.
Yeah.
So they look at cloud as part of their ecosystem, and they don't want to lock you in their cloud. Of course they do, but they try to lock you in their cloud through their ecosystem, not specifically through their cloud.
Yeah.
And they make it harder for you because once you integrate everything and you use everything Microsoft, it's just natural to use Azure.
It's exactly the same as it was before the clouds, especially with this vendor. Nothing much has changed in that particular direction. Yeah.
But
I agree. Maybe it's also, I don't know why, but it's kind of also AWS is being more connected with when you are about to run any open source technology. It doesn't matter at all. You can run most of them on any cloud, but it's like in people's heads a little bit more because exactly as you said, the more popular programming languages, which kind of people again connect with particular open source tools just because they kind of play well together. Yeah, it's true. It's more of an ecosystem thing than a platform.
And the other interesting thing with this trend of trying to lock you in is how you they lock you in once you're in. The question is how they get you to come to them.
I think that's easy. Like this is like the real no-brainer for clouds, that when you're small and you're looking for infrastructure cost which grows with you, that a cloud is like your perfect playground. You start small, pay small. As soon as your business grows, your infrastructure, operational costs and everything, which differentiates the cloud from your on-prem investment, which needs to be significant no matter how small you go. Because many people only compare the price for the bare metal and compare it to a cloud cost, which of course doesn't make sense because the skill set that you need to set up a data center, no matter even if you rent the infrastructure in there, everything that needs to happen is quite significant again. So basically here it's also a shift of responsibility and a shift of, I don't know how to say it, of know-how, even if you so want. I can show you a number of clients, especially smaller companies that we worked with, for whom it's not even so much the cost, it's the lack of self-confidence that they will be capable of creating an operational infrastructure which is scalable enough, safe enough, fault-tolerant enough, and so forth, in order to be perfect in the beginning, especially during the growth phase where you can't permit yourself to have outages while you're still trying to gather momentum on the market. You need to be brilliant, and for them cloud is a no-brainer. So basically here the hooking a company in order to start, especially when they're small, is really easy. And then it's the usual tricks, like you start them on a standard tool, be it search, database, whatever, and you start tweaking it. Then you tweak it a little, then you tweak it a little more, and 5 years into the game, it's been tweaked so much that if you want to switch back to the standard solution, you can't. You have to refactor, you have to change protocols and so forth. This is a game that we've been playing with off-the-shelf products, with so-called open databases that follow standards and so forth. Before cloud and before even distributed computing, this was a thing. So this is simply just continuing there. There's nothing new about that.
Yeah. And the other thing is, of course, we'll talk about the architectural implications of cloud later, but one of the things that cloud makes easy is it takes care of all the ilities, scalability, security, whatever. And then to some extent, of course, but it's much easier than to care for all the parts of your system on your own.
Definitely. That's what I meant with outsourcing the know-how. Yeah.
Yes, and the other aspect is of locking small businesses in. I checked today, by the way, all major clouds have cloud enrollment programs for startups, for scale-ups, for growing businesses. There are different aspects. most of the programs, if you look at the different pricings, they're virtual money, of course. They're tokens. They're cloud usage money, but they hover around the $100,000 mark for most startups. Some give less, some give more. The biggest one I saw was $150,000. There, of course, Alibaba gave $50,000. So, and everything in the middle.
Yeah.
But the idea is, you have to prove different. Some of them actually have tiers. So if you have a venture capital backing, you can apply for more or less or whatever. But the idea is you get free clouds in the beginning. There was no joke that only in IT we call our customers users. There are two industries that do that. IT is one of them. So the problem is you get your users, you hook them to your product, and then demand payment. So initially you have to throw them a bone, so to speak. So that's the cloud addiction model. And the great thing is clouds, they know that out of 100 startups, 99 are going to fail, and that investment will be wasted. But then the one that becomes the next whatever, a huge platform, then that platform will pay for all that usage and plus. So it's a important way to, when you start small, you have to recognize the moment that you're scale up and start thinking whether your business model works well with cloud as you grow, because the pain from that business model will grow, and you might end up paying pretty much your whole revenue or close to your whole revenue just to run the cloud stuff.
I agree. It's, I mean, the term FinOps was also coined quite recently, not really recently, quite a while ago, but for me it was just a few years ago. I don't know how many, until I met a client that actually had a person who had that title. They were a FinOps whatever, manager, engineer, I don't know what. And I think here this connection that we have now, which is between the finances of your company and the operational aspect of it, is something which is, it's not new, it was always there, but this direct connection between so much fine-grained control that you have over your operational costs and the financial impact as it has is something new, because on the cloud you have lots of levers and lots of tweaking options which you actually don't have if you're purely on-prem or if you invest in your own equipment. Like for example, turning off infrastructure for a while and it doesn't create cost. Speaking with your financial department and, for example, having a talk about if we make this service slower, it will save this and that much money. What do you think the effect on the users is going to be? Are they going to pay less because we made their user experience worse? Or is this a feature which probably not so many will notice, and the one that will aren't relevant financially? These are talks that didn't exist before. The main connection which existed before was between product people and finance. So you're speaking about features. Do we need this feature? And how is it going to affect the finances of the company? Currently, especially with FinOps, you have financial people speaking with DevOps engineers. And this, at least for me, this is relatively new, at least in this in the speed that it's happening and how much it's happening at the moment, because this fine granularity of control over the cost that your infrastructure actually creates is incomparably more powerful on a cloud platform than on anything that you might run on your own in on your on-prem infrastructure. So this is interesting and new, actually.
It's natural because the again, a company grows by its customer base and revenue and so on. It dies by its cash flow, but the way that companies paid for IT changed significantly. Back in the day, they treated IT expenses mostly as capital expense. They pay once, then they have assets, they have depreciation of those assets. It was predictable. They could budget on that. They can predict. We'll need new servers in X years, blah, blah, blah.
I remember these days, yeah.
Yeah, and now it's an operating expense because it comes from the top line. Regardless if you make any money this month, if you have that many active users, you have pretty much that operational expense.
For many, you don't even need active users.
Yeah.
Just to be there, you have.
Yes, of course. Yeah. And that changed the game. That's why I at some point I even expect to have like I'm not sure if FinOps is like a mashup of DevOps and finance, but yeah, that's
exactly what it is. Yeah.
That is going to become a more and more important, especially in cloud product companies. That will become an important role at some point, because when the CEO looks at the expenses of the company, if you run on cloud and your products are in cloud and so on, that's a sizable portion of your expense.
That's not in the future. That's happening right now. At least during the last few months, I've been involved in at least 3 such engagements where clients had kind of a side request, help us optimize our cloud expenses. And the interesting thing there is that in order to help them do that, you have to do quite a lot of research. First, you need to understand the product, how it works. You need to understand how they work. So you can't simply go over existing cloud infrastructure and say, turn this down, scale this down, and so forth. You need to understand the whole business model, the whole seasonality that it maybe has. You need to understand priorities that they have. This is important. This can be slow. This can't be slow. This is like our, this gives us market edge. This one needs to be brilliant, and so forth. And taking this input from the business side, translating it into financials, then doing the table which says, here we might optimize this one, don't touch it, and then projecting this on the DevOps side of things and turning it into numbers is something that it's not really new, but definitely in the last 1 or 2 years, at least from effort also what my team has, this exploded. This is also when we have requests for software architectures on the cloud, which like the main thing that we're involved in, the cost part of it is always there. Like you can't just come up with a solution architecture. Since it's on the cloud, the first question is make a projection. And then you are then you are basically you put your architect hat away, you get the finance guys, the really easy to use calculators that the cloud platform says, where you can
just input the DPUs and you'll get the exact amount.
So this part of the job, so to say, that's not future, that's happening right now.
And there is a recent trend, maybe not so recent, but from last year. For example, Salesforce was made a hike in their prices for cloud usage for the first time, I believe, in almost a decade. So in the last few years, there is a trend of increasing cloud costs and pricing models, but even for the same stuff, companies start to pay more in cloud. And what's your take on that? Why is that happening?
I mean, cost in the last few years is rising for everything. For cloud, first you have the natural reasons. I guess energy is very relevant for cloud, and it's going upwards without any intention to go backwards. At least how it looks at the moment. Worldwide, we had quite a lot of inflation, which again is just natural. It doesn't matter if you're speaking about cloud cost or anything else. For some of the things, it's the cloud cost for particular services is coming natural due to the complexity of the platforms that we're using. All of the modern services, no matter if it's Salesforce or any other, year by year they generate more data. Even if it looks to you that feature-wise things might not have changed that much, analytics getting a lot heavier, big data becomes more and more interesting. With this AI boom that we have, Everyone is loading data like crazy onto their platforms. The processing power that they need, even for a small thing that gives you suggestions that you might not be using, is enormous. Especially the currently optimized models the currently utilized models aren't really optimized still. We are in the process of doing it. That's one of the things that many new promising companies are working for, to make them more efficient simply of the resources that they use. At the moment, we're in a bad spot there. We have quite some promising functionality, very fast adoption, but they work horribly in terms of how they handle their resources. And as things that everyone is stuffing into their products, you have the side factors which we can't influence anyway, and that just makes the curve go up.
Another two aspects that might be contributing to that. One is, of course, the market got pretty much oversaturated. Most of the companies that wanted to go to cloud, for the most part, especially the biggest companies,
I agree.
they went to the cloud. They got entrenched or put roots into the cloud. They became dependent on the cloud, and now the cloud providers feel that it's harder for them, the price of switching to somebody else, or and so on. And also the aspect of back in the day when cloud became prevalent, because officially it started in 2002 with AWS, but for the past, I don't know, from 2005 to 2015 or 15 definitely, the Moore's law still holds sway, and you can expect that next year you'll have much more capable hardware, or the same capability of hardware for much cheaper, and so on and so forth. And that made sense, that the guys that can buy hardware in huge quantities can actually make quite great deals, and you don't have to change all the time the hardware just because there's new capabilities and it's cheaper and whatever. And it made a lot of sense, at least for the commodity layer services like compute, storage, and so on. It made a lot of sense to run them in cloud because it was more predictable, because at some point you don't care about changing to the new whatever processors, new capabilities basically. And it gave you this abstraction that you can take advantage of the new capabilities, but not necessarily pay the full price every year, literally. And now that's no longer and by the way, it literally yesterday I watched basically a video about the latest AMD Ryzen processors. They claim that Gen 5 compared to it's Zen 5 compared to Zen 4, the difference is 16% in terms of performance on average. So long as, and those are two generations, different generations basically. 16% is nothing. 10 years ago, people would laugh if you go on a stage and say, our new generation is 16% better than the old generation.
They expect to hear 16 times.
At least, or 2 or 5, basically talking in times, not percentages.
I agree.
And basically, we're nearing a plateau of what we can get with the current architectures. With, of course, ARM gives us some breathing room there, but the way that we're doing things reaches basically the law of diminishing returns kicks in, and we must invest more and more for smaller and smaller returns on that investment. And at some point, even if you can get the twice as powerful processor, but for 16 times the price, you wouldn't care, you wouldn't switch to it. So there is no financial sense in AMD or Intel or whatever to make the investment to produce such a processor. And that translates to cloud as well. They cannot get that improvement so fast. and at some point they have their expenses. They produce ever more complex services, of course, and run them on their infrastructure, and they need to hike prices.
Yeah.
So I believe those are the two main additional reasons to what you said for the recent price hike. And of course, there is a perceived price hike because some companies, and actually, at least in my experience, and you can share yours, a lot of companies didn't migrate to cloud. They migrated to cloud prior to understanding how cloud works.
Definitely. Like one thing, I don't know how to put it. Everyone understood that you can't take a system, run on whatever EC2 instance or whatever, and simply put it there, that it's going to be ridiculously expensive. Everyone understood that. What people, I think, mostly for the general part, didn't understand that apart from adapting the architecture and the setup of systems which you might want to migrate from a physical platform onto the cloud, is that you need to change how your company works, how it ticks, how the culture is, how you develop, how you operate things, how your development teams are structured. There are many aspects of this. I've participated in quite a few migrations where the most difficult part wasn't the technical one. That was the easy part. Changing how the company then works, how the teams are structured and so forth, is the hardest one. I'll just give one example because the topic is really way too broad. This is more like for a separate session. Is if you are a siloed company, you will struggle extremely when you move to the cloud. The more you've shifted your DevOps left, your testing left and your DevOps right, so that development and operations are kind of one anyway, and you're automating and testing early as much as you can, you will have a much smoother ride while doing it. Sounds easy, sounds kind of logical, and many companies nowadays think that they are already there, but they aren't. So this is like one of the things which is the big blocker usually, which when you start it, you migrate and things just keep on breaking, they keep on being expensive, you are promised fast time to market, but you don't have it, and so forth. Yeah. So the one big example that I would give here is exactly this one, that you actually need to change the way that especially the engineering part of your company, but not only, we already covered finance that need to be involved in different ways. There are other aspects as well. This is like a banger, which is almost always valid.
That reminds me of a few years back, I was taking part in a mentorship program for scale-ups. And one of the presenting scale-ups, they were so enthusiastic, you know how IT companies are always the most enthusiastic on pitches. Yeah. We're gonna change the world, at least. Yeah. And they were so energized, and they came on the stage like they own it. And I asked them a question because there is a saying, infinite loops are quite fast on the cloud, but they're not cheap. Yeah. So, and you can create infinite loops in ever more creative ways than ever. Mm-hmm. I have a story to tell with a huge bill that racked up on a dev instance of cloud infrastructure.
Let me guess, it involves a lambda and something which creates a trigger, and the trigger triggers the lambda.
Yeah. So the trigger around the lambda.
Just to interrupt you here. There is a fix. So basically, Amazon rolled out a detection thingy that detects such loops. Yeah. It's not even rolled out on all regions yet. So you can still do this.
Of course. At the end of the day, you're the one that pays. So
here, to be fair, I've been in such a situation twice. You pay it, but they give you the money back. Actually, they do that. They're not. They might be evil in some situations, but this one is like fair play. One time the cost was really significant. Everything returned. I must say.
In the case that I was involved as well, they actually we paid a small portion of the sum, but for the most part, they just gave up and said no problem. We see that it's a dev environment. It's not exposed. It was a mistake.
Funny how everyone has such a story.
Yeah, and I asked those guys on the stage, hey guys, how do you do your how do you monitor your cloud infrastructure for such events, for infrastructure? Somebody will do a deployment on Friday and leave. Back then it was S3 bucket. You put something, it triggers a Lambda, it does a blah, 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 blah. But it ends in the S3 bucket. And once it's deployed, it's a never-ending cycle. It brings up a lot of infrastructure to do the stupid thing you said it should do. And they didn't have an answer. And they said, well, tonight we'll put in mechanisms because
for a scale up that's concerning when they don't have an answer.
It's not a startup with 50 customers or something. But the another thing about the recent development of cloud is that at least a lot of people that work with cloud technologies on a daily basis seem to have the notion that cloud has somehow slowed its innovation pace. Because back in the day, things were moving quite fast. New services popped up every other day and so on.
I remember a time where you opened the AWS console, you kind of thought you know your way through. You went on vacation for a month or something like this, open it again, and it was like, what happened?
So why do you think that is?
I don't think cloud really has stopped innovating. There are some quite new exciting things, but you said it in the beginning, we are not at the top of the hype. You don't need to add new things and get new people hooked every day. Effectivity, being effective with things becomes a lot more important because, as you also said, one of the things that cloud providers are doing, they're not only fighting to onboard people, but also to hold them there. And there it's not that much about new features that you're not sure if you need them or not, but actually giving you reasons to stay there every new day and so forth. I think in this direction, there are things happening, but definitely I agree that like this, the momentum that it had a few years back has definitely disappeared. Here, again, I don't really feel qualified to dig into what talent stays where, but there is definitely kind of a little bit of a migration of the top tier talent from cloud companies and from some of the flagship products that clouds actually had, shifting into other directions. Definitely that whole AI boom has something to do with it. But again, I mean, if we had cloud still on top and being one of the most important technologies, it definitely wouldn't be happening in such scale. It's happening currently. So long answer short, I think innovation is there. It's still happening, but it's not so much in your face. It's not so much obvious as it used to be. It's more, again, as you said it, more on the plateau of productivity, basically making things better, more effective, and so forth. So it's still there, but it's definitely not that visible.
And some of the notions that people working with cloud have as of the last few years is there might be a trend starting to appear that companies start at least partially moving away from the cloud.
Oh yeah, definitely, and it's not really partial. I've been involved in both migrations from on-prem to the clouds, and one just 2 years ago or something like this. The other way, it's pure math. Basically, you sit down with your FinOps guy and you start making the calculation for the next 5 years. I will put my stuff in a data center, how much it's going to cost me, how much is the cloud operations going to cost. And for some companies, giving some specifics that might be there for things that might be very hard to optimize, which does happen. For some businesses, they have specifics that you simply can't use, for example, for some reason you can't plan your instances nicely and you use a lot of on-demand instead of reserved. For some reason you can't predict what kind of instances you will be using. Your storage cost again might be a surge based. When you have surges in the in data which needs to be aggregated, and you need to have this perpetual readiness in order to hit it. There are very valid situations for businesses that have moved, that they've gone full circle basically from on-prem to the cloud, being disappointed from what they were thought they were going to save. And they're not only thinking about it, as I said, we have a few examples from companies that completely migrated everything. I mean 100% of the infrastructure back to a physical data center. And their current projection at least shows that within 5 years this is going to pay off. And after these 5 year pass, it is really going to pay off. So it happens, it's very specific. There is a reason that we involve finance and operations quite early on. I think it's a valid thing. So I don't think there is a trend in either direction. I think there is more consciousness. So basically that cloud isn't the silver bullet for everything, that there is a whole set of valid reasons why to use on-prem. And in most of the cases, the solution is, like with pretty much everything, somewhere in the middle. This is also the reason why lately we see more and more hybrid solutions, more than in the beginning. So this all-in cloud thing definitely has slowed down a little bit. But really paying attention to the different components of whatever makes up your platform and deciding piece by piece what to operate where is definitely something to think about.
I would add that some of the notable examples that I managed to find are Dropbox, which entirely moved off cloud. It used to be on AWS, now it's in its own data centers. Apple Cloud, another notable example, they created their own data centers, moved away, primary reason being cited cost.
Yeah.
Also Pinterest, Uber, a lot of notable companies that moved away from cloud, and most of them pretty funny. Most of them are coming back from AWS, by the way. But that has a reason behind it. Most startups start on AWS as well.
Yeah.
So the ecosystem is much more vibrant and dynamic there as well.
They're also connecting both things, this trend with hybrid solutions, which actually also kind of even circles back to the innovation. Most of the situations, just out of experience from the things that are currently going on, why clients shift towards the decision to go with a hybrid solution actually isn't just cost. Quite often it's security and compliance. These are two topics which are extremely relevant because we work in domains that are under heavy regulations like healthcare and fintech. These are two examples which we are quite involved in. And there it's very interesting that like the first thought is always, okay, like the part that needs to be under regulations, we just put it on-prem, and anything else we put on the cloud, which is a very naive approach, but sometimes it goes in this direction. It actually makes sense. What I also particularly like here, the innovation which is going on in the cloud for this is, for example, the concept of confidential computing, which basically until now we just thought about the safety about on our data when it's in transit and when it's stored somewhere. But what happens with the data when it's being computed? So exactly here, this is it's not a new thing, but it's really gathering momentum really, that you have these I don't know what the name of the units was, that you basically say, I'm encrypting the data even when it's in memory. I create a trusted unit that will on the lowest level eventually decrypt it while it's being processed, and by doing so creating a this time really end-to-end encryption option in the cloud probably with the idea of being compliant with regulations and being able to move your data a little bit freely without breaking compliance or being on the wrong side of a regulation, which is also very interesting.
Yeah, there were recent, I wouldn't call them incidents, more so, because there were vulnerabilities found in major processors, mostly with regards to branching logic, but not necessarily, that actually can expose your data while it's being computed.
Yeah, exactly. Yeah.
So yeah, definitely. And the other thing that I think contributes to some companies taking the decision to go off cloud is, again, coming back to the beginning of our conversation, the necessary prerequisites are there. Out of cloud, initially cloud was generally born out of virtualization plus faster internet infrastructure. And now out of cloud, and not only out of cloud, out of basic features, for example, of Linux, of the Linux kernel, bundled together, we call them Docker, basically.
Yeah.
But out of various things came virtualization that can give you scalability on-prem. That was hard to achieve back in the day. And basically you have a tool set that can give you, of course, if you are looking for some specific things that cloud can give you, you cannot easily recreate them, but scalability is not one of them, because it's more easy than ever to create scalability on-prem. And that was one of the major selling points of cloud back in the day.
Here, touching the topic that you also mentioned in the beginning about architecture, about designing systems, which I 100% agree that even if you take an on-prem system that you're currently designing, once having been through the whole journey through the cloud, where it's fully natural to have elastic scaling, microservice architectures, serverless architectures, where you're not even thinking on the level of a service, but completely ignore everything and just think in functions, has an effect on architects, so that when they get confronted with now designing a system which is even, let's say, one that is supposed to be running 100% on-prem, they do it differently. So exactly these constraints with the pure givens of the cloud and the options that they gave you, they started missing at some point at the on-prem deployments. Then happened exactly what you said, that currently the tool sets that we use on-prem support these out of the box, and you're perfectly capable to creating something which actually looks more like a serverless architecture, but you're running it on your own servers that you own. So this is something which I actually found very fascinating and a very positive development on how we think about system architecture, purely because of the presence of the cloud. It's not that we needed it. We were perfectly capable of doing this on our own, on our on-prem infrastructure, but no one did it because the resistance was too high, because someone had to invest in these frameworks and everything which basically surrounds the non-functional part of things in order to have them develop. The cloud gave us to many people for free, and it became something more of a way of thinking, so that if you now don't use them, your solution looks wrong. Like people ask you, why you're not doing this? You're wasting resources here. I mean, back in the days, we started a whole new server when we needed more resources that had everything in it, no matter if you needed it or not. And this way, having this infrastructure and going full circle back to a more traditional solution changed it, which is very interesting.
And in architecture terms, most of the architectural, I would call them styles more than patterns necessarily, because like microarchitectures, like serverless architecture, if you take the purest form of microservice architecture, every microservice needs to have its persistence. And try to do it on-prem. It's a nightmare.
Yeah.
So the trends, because of cloud, we started doing architecture approaches that are best suited for cloud. On the other hand, they lock you into cloud because good luck running those hundreds of functions or lambdas or whatever you've written on the cloud on-prem. So it's interesting game that cloud influenced us to think in terms of cloud when we design systems, and those designs are not good for on-prem always. So that's another way to vendor lock you in into a system. And the other thing is that's usually neglected, by the way, and I personally believe that's the biggest impact of cloud that it had on everybody's life, is cloud created an environment because everything is scalable. You pay as you go, you pay as you use. If you're a company that provides a cloud service, you need to transfer those expenses to your customers in some way. If they use more and they incur you cost, you cannot just say, hey, you have a perpetual license for my platform because you gave me X money. That's and whatever.
Yeah. Now it's everything is as a service.
Yeah.
Yeah.
Recently, I literally a few weeks back, I heard for the first time the so-called wet leasing of airplanes. It's basically airplane as a service.
Yeah.
You have the crew, you have ground maintenance, you have the aircraft for a set period of time. You use it as you wish.
The heating of your seats in your car, as soon as you stop paying, they just turn it off. You need it as a service because some cloud platform maybe needs to be paid somewhere.
Yes. So
yeah, definitely. No, this is a very interesting part of the whole thing. How maybe we close the circle this way, more or less. That it actually changed the way that we speak and the way that we perceive products. That at some point, for us, it's still weird. The next generation, even like not having to pay perpetually for something is going to be weird. Like you're going to be feeling like it's you don't have it. Like So this part of simply buying something and then taking it for granted that it's yours forever now, is maybe a thing of the past.
Yeah. Because of the models that basically the cloud providers introduced, and it went past cloud services. It went, as you said, in the heating. You pay for having a heating of your seats.
But afterwards, you still need to.
Of course. And that's a pretty interesting model. And now it's the norm. You don't own your IT infrastructure. Again, coming back to architecture, it's for example, it's infrastructure as code, but it's written in a language that only one cloud supports, whatever. But again, it changed the way we think about doing IT. Everything is service, everything is basically a subscription for you, and so on and so forth.
Yeah.
And closing today's session, of course, we should look further and what's next. And it's hard to predict, of course, but there are trends that we can step on and use, of course. So what do you think is the future of cloud? We mentioned the trends of companies going back from the cloud. Is that trend going to exacerbate for cloud providers, and maybe huge companies will start to leave the cloud? Or
I don't think so. Like I don't feel I can predict how things are going. What I can share is maybe things that I think are going to be exciting around clouds and say near to midterm horizon. We already touched on the point with the multi-cloud and hybrid solutions. I think they are on the rise because people are becoming aware how they can optimize things, what's better for what, and exactly this productivity plateau, as you said. Once having settled down, having understood how everything works, now they're really trying to use it to the optimum, like take the best out of the different options that you have. So I think here hybrid multi-cloud solutions, I think, are going to be very, very relevant in the near future. Something which is interesting. Edge basically is a synonym for cloud currently. Yeah. No one makes their own edge locations. Some do, but they have a reason for it. Yeah. But they are outliers. In the usual case, there's a lot happening there. Changes, new things, optimizations, behind the scenes and quite visible things as well. And maybe something more exciting, because these are kind of, I don't know, everyday things. I'm very interested to see how quantum computing is going to coincide with the cloud at some point. Because this is, again, one thing which building it and having it is not really something that everyone does. But on the other hand, it has very broad applications, and it makes sense to share it, to have it as a commodity or something that can be used in an abstract way to simply let it do its work. Again, somewhat in the early stages, but not really. Quite some breakthroughs there as well. And definitely something that I am excited to see how it's going to go forward, what's going to happen on this front.
With regards to quantum computing, the biggest player, the biggest network of quantum computers worldwide, by the way, is not operated by the usual suspects like Microsoft, Google, or Amazon. It's owned by IBM, and they have like 100 plus quantum computers, and not just quantum computers, but they boast that all their quantum computers use more than 100 qubits. So every single quantum computer you can use, I checked them up, by the way, the only physical quantum computer of IBM is in Spain, in Europe, I mean, which bothered me, because if you look at the east coast of the US or southeastern Asia or different regions, there are multiple quantum computers. Europe seems to be lagging on that front, or IBM is not investing that heavily in this. I don't know. But quantum computers definitely will be something that you cannot operate on your own or at home or in a data center.
Not for a while.
Yeah,
no,
it's quite academic even to get it running. So and definitely
keep
cloud.
It running also,
that's an interesting thing.
Yeah.
Another is, and I've said it many times in the past, cloud gave us a lot of things that we wouldn't have without cloud. To give a short example, I can give many such examples, but currently we are in the AI hype. We wouldn't have the models we have today without cloud, because cloud enabled gathering of huge amounts of data, cloud enabled training of models, cloud enabled even now the huge models that we are running, hundreds of billions of parameters. As you know, the smaller models like 8-10 billion parameters, whatever, you can run on your machine, but hundreds of billions, definitely.
It's painful, but you can.
There is not a machine on the planet you can run hundreds of billions of parameter models and actually run them in real time for multiple users and so on. So cloud again gave us the ability to run such models. So I'm excited on what cloud will enable us in the years to come. I'm pretty sure cloud will stay, and the main reason is the trend of how we gather data. It's ever accelerating, it's exponential. Every 3 years, we gather more data than in the previous human history. So definitely that trend will continue, because we can no longer store our data, the data that we produce locally in any way. We cannot process it. More and more people are producing data every day, and the data that each person produces also grows, because we have, for example, cameras with high resolutions. We shoot more videos or whatever. Back in the day, we used to shoot pictures as a culture. I mean, selfies, whatever. Nowadays, everyone is shooting videos. So the amount of data that everyone produces is growing. Various countries, the last part of the world that currently is experiencing a huge boom in mobile phone usage, smartphone usage actually, is Africa. India is already past that revolution. China passed it even before that, and so on. So at some point, we wouldn't have more people to onboard to the cloud as users, but definitely people are producing more and more content. So there is no way for us to continue with that lifestyle without cloud. So that secures the future of cloud in a way. Yeah. And so the future of cloud is definitely great. And hopefully it will give us another more and more actually revolutions because it exists and because we use cloud. Because if you to give an example back to AI, if all the data was in different data centers and siloed and so on, you couldn't do much things with it. We couldn't create models easily or whatever. Not that the creation of those models is always, how should I say, transparent and so on, because there were a lot of issues with how Copilot was created based on code from GitHub. So, of course, having the data in one place enables us to do things for good and for bad as well. But definitely there are interesting things that will happen because cloud is a commodity nowadays and everybody uses it and so on. So we'll see what happens. The future definitely will be interesting. Not just quantum, but yeah. So thanks everyone for joining us today. Hopefully that was an interesting discussion. It certainly was for me. Thanks, Moni, for the
thanks for having me.
Pleasure. And yeah, thank you. See you next time.